Hi, everyone. Welcome to today's episode of the TelcoBridges Podcast. My name is Maximilien, and I'm the CEO of TelcoBridges. Joining me once again is Luc Morissette, our VP of Client Technical Services and a founder of the company. Today, we're talking about out-of-band shaken. On April 29th, 2025, the FCC issued a notice of proposed rulemaking with regards to out-of-band shaken. So today, we'll talk a little bit more about what it means, why the FCC is talking about it, and explain why this is not something that service providers need to worry about. So, Luc, today's discussion was catalyzed by the FCC's notice of proposed rulemaking, but I think it's worth mentioning that the FCC serves as a bit of a lightning rod with regards to international regulation as it relates to telecom markets. And so often what we see is that whatever the FCC kind of talks about or implements ends up being, implemented, maybe modified, but kind of implemented and applied in other markets for the listener's benefit. And so what happened factually is that this year, April 29th, very recently, the FCC issued a notice of proposed rulemaking for out-of-band shaken, and they're asking for the industry's opinion on how service providers with TDM in their network should implement out-of-band shaken. Out-of-band shaken is an important kind of step in the effectiveness of stir shaken, and another step towards us as an industry increasing the level of trust in kind of the public switch telephony network. And maybe a good place to start is just explaining a little bit about stir shaken as a reminder for the listeners today.
Yeah, for sure. So stir shaken is really a way to verify who's calling. Right, so you get the call in the system and you verify, is this a valid caller? Once you get this data into the network, it can be verified. There's some validation certificates that you can have for these numbers. And then you can verify if it's on other lists as well. So you have some other blacklists that exist. So you can remove those numbers from the network. And then you can do analytics on these numbers. You can do blocking these calls if it's really a fraudulent call. And then it can also be used for trace back for lawful interception, right? So you can trace back who has been calling and then do some analytics on that as well. This is done normally on SIP, right? On SIP networks. And it has been deployed for years on the SIP networks. However, on the TDM networks, it has been studied for a while, but it's not been implemented a lot in the networks yet. So there are solutions for that. Right?
Got it. Before we go to the TDM side, I do want to stay on stir shaken for just a second. So as I understand it, and the mental model I use is, there's this concept of implicit trust if the originating service provider knows their customer. And so the idea, and correct me if I'm wrong, but the idea is if the originating service provider knows their customers and then this call is originating in that network, the originating service provider should know them. And so he should be able to attest in the call information that gets sent, through the network, that he can confirm who this caller is, and then whoever's receiving the call should be able to say, okay, well, if the originating service provider knows who this is, then I should be able to trust who this is, and there's implied trust throughout the network. Is that the right way to think about it?
That's one way that can work. However, you don't necessarily know where the call is coming from sometimes, right? So if it goes through multiple different carriers, maybe you want to verify at another point in the network, is this still a valid call, right? It has not been modified or tampered with, right?
And that's why there's encryption, etc., on the attestations,
Correct. So if it's the originating that gives its own attestation, well, then you can receive that and say, yeah, it's good. But if you have it encrypted, verified with certificates in the network, that makes it a whole new level, right?
Got it. And I do want to talk a little bit about the ABC attestations. So ABC, we were just talking about it offline. Again, correct me if I'm wrong. A is the originating service provider definitely knows who exactly is calling and can confirm. B is the originating service provider is not sure. And C is the originating service provider knows that it's a malicious actor. Is that the right framework?
Yeah, hopefully they don't send it when it's a malicious actor, but but it can be verified. Like I said, the same attestation can be done other places in the network. So that's why we have those levels valid, right? So the originating can know that it's your DIDs that you have, your numbers, and then they can verify that's what you send. But later in the network, you need to verify some other way to verify these numbers, right?
Got it. That's helpful. And can you maybe I can ask why it's been so easy to implement in SIP networks, just as a final starting point here before we move on. But so the history, and maybe we can tee it up with the history. So the networks were originally built with TDM, of course, which is a kind of rigid set of standards that were designed for the utmost kind of reliability. SIP came after. Stir shaken is this SIP native concept, and so it makes sense that it works in SIP, like as a SIP native concept. And then now there's this application of trying to make it like interoperable and retroactive to the technology that was developed before. Is that like, how do you think about it?
It's exactly right. So TDM were designed in the 70s, and it has very rigid specifications, ITU, ANSI specifications. Every field is defined. You can't just add a field randomly and it won't pass in the network, right? However, in SIP, you can add a SIP header. If networks don't need to read those headers, they just let them pass. But at the other end, you can then read that header if you know what you're looking for. For example, the identity header for stir shaken, then you can capture that data, and the data can be anything. And in this case, encrypted data. Right?
What you said was interesting there. In SIP, you could manipulate headers pretty easily. In TDM, there's a rigid set of headers that everybody conforms to and that are not designed to be manipulated.
Correct. And the other thing is these devices that are TDM based were designed long time ago, so they don't have those new stir shaken capabilities. And there's probably nobody to modify the software of these devices. It's done in very old software code, so very difficult to modify.
Look, we've talked a little bit about the problems implementing stir shaken when there is TDM in the network. The catalyst for today's conversation is, again, the FCC Notice of Proposed Rulemaking, and in it they discuss potential solutions. There's two main solutions that the FCC is asking the industry about, colloquially known as in-band and out-of-band. And maybe you can explain to the listeners the difference between the two.
Sure, I can do that. The in-band solution over TDM, since these protocols are very rigid, it's difficult to add data in there. But there's one field that's called UUI, so user-to-user information, which is pretty open to be used by anything. And it is being used by different things in the network. So that means some elements in the network can modify this field. Okay, so the trick is that you can put this encrypted identity information inside this UUI field, send it over the network, and the other side can receive the UUI, unencode it, and then verify if it's a valid call. Unfortunately, with our testing, we have found that not all the networks will pass the UUI. So it is possible to use it, but may not work in all cases. All right? So it may not be super reliable. The other way to do it is with specific lines, right? So you could have specific trunk groups to carry this information. But then again, it becomes complicated because you can know the next hop of your trunk group, but then all the next hops needs also this trunk group to make it, all the valid calls will pass through these trunk groups. So it is tricky to do the in-band solution.
Okay, that's super helpful. So allow me to double click. So method one is to use this UUI field in the signaling. Method two is to use a distinct trunk or group of trunks for the attestations. Got it. And the difficulty is that, if the originating service provider, the call then goes through one, maybe two, maybe three kind of relay points, if you will, before reaching the terminating service provider. The question is, what are those relay points going to do with those fields, and have they been kind of programmed or adjusted or configured to be able to receive and pass on that information? Is that the right?
That's exactly right.
Got it. So it's a coordination and willingness problem among the broader group.
Exactly. That's like I mentioned before, right? Some switches that may be in the middle of this call path may just not be possible to change their behavior, right? It's just too difficult.
Got it. That's super helpful. So that's the two things you described. Those are in-band methods of implementing and passing along stir shaken attestations in TDM signaling.
Correct.
Got it. Now, the other suggested solution by the FCC is out of band.
Correct.
Can you explain a little bit of what that means?
So out of band, what we do is we use external services, which are much more modern than the older TDM switches. And then we capture this data, send it to a central location. I think they call it a call placement service inside the FCC documentation. So it's just a place to store the data, which then on the receiving end of the call, it can also verify, was this call placed by the correct original caller, right? So the data is in a central location, a central database that's accessible by the originator and the receiving end, okay? There's some additional stuff here, is that one is the data that is sent from the originator needs to get to that central location quick enough so that when the call arrives at the other end, it can read the data. The data must exist before it can make that call. So the data needs to be pushed quickly in the network. Second thing is that you want to, this data must stop at some point, mean that become unavailable at some point. So that not other users could reuse the same key, right? So then after X amount of time, and I'm trying to remember, is it 20 seconds or maybe even less? If in 20 seconds it has not been queried by the receiving end, the data is destroyed and it continues.
Got it. That's super helpful. That was clarifying detail. Hearing you describe this, it reminds me of other third-party database services that we come across in service provider voice networks, like a DNO list, toll-free routing, right? Some of those things work similarly, whereby information about an incoming call goes to an external database, comes back into a switch or an SPC. And so it sounds like, this out-of-band implementation would be something similar to that in construct and framework. Is that right?
Absolutely right. It's the same framework, same way of working. That's why a lot of our partners will do these different services together. Stir shaken has one more thing, is that it needs to validate and get a certificate, right? So that's just one more step to do. But in other cases, it would be other things that the system needs to do, right? So.
Got it. That's super helpful. It's probably worth noting, after having gone through the notice of rulemaking, it's not crystal clear who the authority would be that manages that central database. At least to me as of today. So there's probably still some kind of outstanding questions in terms of exactly what that would look like. But as a concept, it's just basically sending the attestation not in the TDM signaling. And when a terminating service provider receives a call that went through that was in TDM at some point, they need to go check that central database for the attestation.
Yeah, that's right. Exactly.
So, Luc, correct me if I'm wrong, but while we don't know where the FCC's rule will end up, we have seen in practice and in the field some service providers begin to implement stir shaken attestations out of band so that they can work even if there's TDM in the call path, right? So my understanding is the way to do this today is to use kind of the attestation providers, so the third-party attestation companies that exist. And however, I guess the reason the FCC is getting involved is that there's no unified standard for this kind of implementation. Is that the right way to think about it?
Yes, and also there has not been a lot of implementation over TDM. Right, so I think that's where they want to push it. Over SIP, it's going well. It's progressing. We see it not only in the US but all around the world. It's really progressing. But the TDM part, no, and there still needs to be TDM in the networks. They still exist. You can't get out of that for quite some time. So you need to find solutions so that it's across the board that you are confident with those numbers.
Right. So I guess so perfect. So the summary is there are service providers doing this. There is traffic that is getting attested to out of band, but it's not progressing the way the FCC wants. And so that's the intention behind this effort from the FCC, Correct. Which kind of makes sense. Mm-hmm. Maybe you can explain a little bit how service providers would be able to implement this or adapt to wherever the rulemaking ends up with the Tmedia gateway.
Right. So, Tmedia and SBCs, because we can do in both cases, right? So, we need to work with partners for this, right? So we get the data, we get the signaling information, and we can extract data from the incoming calls and send that to a service, an external service, usually running in the clouds. And then we can attest the numbers and verify, get the calling numbers and stuff like that. And then that's the first part, which is always done in when we want to do fraud protection and stir shaken. Second part is where it makes a difference, right? So then you can get the answer from this cloud service, and then you can insert into a SIP message if it's SIP going into the network. So then you can put these identity headers. We do this with our own scripts, which we described on the other previous podcast we did. So the scripts can allow us to do the identity header. If it's over TDM, then we can also fill that UUI field. Instead of using a new SIP header, we fill the SS7 or ISDN UUI fields, and we pass the data there. The third thing is just to let it go out of band completely. So then the data is sent to that call placement service residing somewhere in the network, and then we have nothing to do on that TDM leg of the call. Okay. So that's the originating side. The receiving side, again, we can get the identity header coming in. We extract that data, and then we can send that to the central system to verify if the number is right. If it's a TDM call, we can extract the UUI field, do the same function. Or if it's a TDM call without this UUI field, then we can just say, well, this is the data I received. You send that to the provider, and then they can verify through that call placement service, is this a valid call? And it returns that to the system. In our system, we can also add a something to the number. For example, a V in front of the call display name, so that when the customer receives the call, he sees that it has been verified and it's a valid call.
Got it. That makes sense. And so it definitely sounds like wherever this shakes out from an FCC perspective, that service providers would be able to implement or adapt via the Tmedia gateway.
Correct. Because it's very flexible, so we can adjust. And we do change. Sometimes the rules change. You see it. New stuff coming out. We just adapt it. It's quite easy for us to do that.
So just as we wrap here, Luc, for service providers who resonate with what we've talked about and have been looking for ways to implement this, I think it's worth noting that whether it's a TelcoBridges Tmedia gateway or an SBC, it is possible to implement kind of out-of-band shaken with our equipment. Doesn't require any major rip and replace or major kind of overhaul in the network. You'd be compliant with whatever standards the FCC ultimately decides to impose on the industry, and whatever kind of like open standards are needed can be implemented via our systems.
Correct. So it's very adaptable. Also, we've seen across the world different implementations, slightly different, we have been able to adapt to that. And if ever the FCC changes mind, adds new rules, we can adapt and change our scripts, change the way it works, and we're sure it's gonna work. Yeah.
Perfect. So that being said, thank you so much for your time today, Luc, once again. For those of you that enjoyed this video, please feel free to subscribe to the channel. We also have lots more stir shaken content in our video library and on YouTube. And for those of you curious about out of band shaken or related topics, please feel free to reach out.